So I ended up with this weird note joint thing. But listen, it's feeling a little bit like the vibe in here is a little bit serious, you know? Sheesh, guys. All right. So here's what we're going to be talking about today. We're going to be talking about dependency injection as a concept because I want to make sure everyone's on the same page. Then we're going to be talking about Angular 2 DI with other projects outside of Angular 2. And of course, Angular 2 dependency injection within the context of Angular 2. A lot of the code samples you'll see are working with the dependency injector directly, which means you can pair it with other libraries like React or whatever you're into. So let's talk about creating objects. There's a few different ways of constructing objects, and that's the fundamental purpose of a dependency injector. Let's take a look at the good old-fashioned way of creating an object. So here we have this class of unicorn, and this unicorn is creating its own horn. And this is problematic because if we want to construct a separate horn for test time, right, we're out of luck unless we start messing around with the service locator. The good thing about this code is it's very straightforward to implement. There's no machinery around the object creation. If you're like, what the fetch is this guy talking about machinery? I'll get into that. Code is easy to understand. That's what I really like about this. Problematic, though, it is difficult to test. In other words, try changing that horn dependency to a separate dependency, right? We've all run into this. And if we haven't, it's because we've been living off of Angular 1.x's injector, which is not a bad thing. This is where the most primitive form of dependency injection comes in. It's called constructor injection. And what constructor injection is it lets us pass in our dependency to our client, and then it gets leveraged or used as a property. There's no machinery around this object creation still. The code's still easy to understand, and we get the benefit of decoupling our dependency from our client. So we're happy, right? We can pass in a mock horn. We're feeling like, all right, this is legit. But over time, it starts to become really problematic. And I call this problem that emerges bleeding dependencies. What is bleeding dependencies? Bleeding dependencies look something like this. You have a unicorn, and you've passed it a new horn. Okay, I'm stoked, but now you have to pass a material for that horn to be used. Not quite as legit, and now you need to pass a power for that horn. So eventually your main method has to know about all of these clients or these dependencies, and all of your dependencies start to bleed out, right? Like the power starts bleeding out of the material, and the material starts bleeding out of the horn, and the horn starts bleeding out of the unicorn. It gets perpetually worse as your applications gets bigger. It starts to feel a little bit like this. And this is kind of graphic, so look away if you're a sensitive person. It gets pretty gruesome. I'll switch it out. This is where the machinery comes in, right? So the machinery is kind of a necessary evil. It looks and comes in different forms, but they're what are called dependency injectors. A dependency injector, say we want a unicorn, and that unicorn has a horn, and that horn has a material, and that material needs a power. Rather than bleeding all of those details out to us, a dependency injector basically gives all of them this warm hug and provides whatever you need. So if you want a material, it'll figure out that you need a power. And if you want a horn, it'll figure out that you need a power and a material. And that's kind of the function that a dependency injector plays. This is the dependency injector we're used to today. So how many of you guys have seen this and I wasted the last 5 minutes of your life? Sorry, not sorry. Okay, I'm a little sorry, but the machinery I'm talking about is all of this code bloat around the object, right? Stuff that is irrelevant to your code, but it's machinery that you have to hook into to play nice with Angular. This code's really straightforward to implement, easy to understand. It decouples the client from the implementation, right? We ask for a horn, and Angular figures out, here's how to give you a horn, bro. You're good to go. The bad parts about this is the dependencies are cached and served as singletons. How many times have you wanted to create new instances and you're beating your face against the keyboard because you wanted you don't want a singleton, but they're giving you back new instances over and over. Or I'm sorry, the cached instance, but you want new instances over and over. And so you're like sneaking it around it by using factories that return factories. Or, there's a ton of different mechanisms. Unfortunately, because of this problem, Angular has two mechanisms for dependency injection in Angular 1. If you think about it, when you're registering a directive, you have the main area where you're specifying your dependencies, right? Where you're like, give me this service and this factory. And then you have a link function that gives you scope, element, attributes. Well, those are both dependency injection patterns, but unfortunately they're different. One is order-based, and they're giving you new instances, and one is token-based, and they're giving you singletons. I'm not sure if we can do better than what we're doing in Angular 2. I'm sure we can eventually as the language matures. But Angular 2's dependency injection is a very beautiful and graceful solution. But I want you to be thinking in your mind how you would implement dependency injection if you had the same primitives that Angular does. Because it's interesting that Angular 2's dependency injection is built with a lot of the exact same primitives that were available to it from day one. The bread and butter of the Angular 2 dependency injector is injector resolve and create. This is effectively a factory to create a new injector instance, and it takes a list of dependencies or bindings. So say we have a unicorn and a horn. We call injector resolve and create, and we pass it a unicorn and a horn. And you can pass this, it doesn't have to be just classes. They can be bindings. But to get an instance out of an injector, say we've created this injector, right? And we have the return value of this factory. To get an instance out of the injector, we use injector.get. So here we're expecting the instance of unicorn happens to actually be an instance of that class of unicorn, and that pans out to be true. But I said you could pass in not just dependencies, because that would lead to a very class-based architecture, which isn't necessarily a bad thing, but you can pass in a concept called bindings. In fact, what Angular 2 will do with the dependencies that you give it is they will turn them into bindings. So what are bindings? Well, you have a token, which is most commonly a type or a class. And you have the object, which is the instance of that type, but it might not be the instance of that type. That just happens to be the object you want for that token. And the binding is the instructions on how to get there. So you're probably used to this. If you think about Angular's one injector, you say .service, and you know it's going to call it with new. Or you say .factory, and those are the instructions. You know it's going to invoke it as a function and return, leverage the returned object. And you have .value. You have a bunch of these instruction sets that are effectively bindings, right? The syntax for this looks like this. You have bind token, then whatever instructions you're going to use, to factory, to class, etc., and then the target object, what you want the factory to be called on. So the simplest example I could come up with for this is binding string, the built-in JavaScript class, to a unicorn. And then we ask the injector, hey, get me back the token string, and it'll give you back unicorn. Notice it's not calling new on that, or it's not invoking as a function. It's just using to-value syntax, and it's just giving us back unicorn. So we're effectively storing this token string, and the dependency injector maps that to the value of unicorn. It's very similar to .value in Angular 1.x, except for you're not limited to just strings. Which is so, can we get excited, please, about that? That's amazing. Gosh, so much better. Okay, to class. This binds a token to a class. We have an animal, and we're binding it to the class unicorn. We expect that when we get back the instance for animal, that will be an instance of unicorn. So this is not quite like an alias, but it gives us back an instance of a separate type of class. So this is like a service that you say, hey, I'm going to map this service to this other service, and give me an instance of that service. It sounds convoluted and confusing, but it's actually pretty typical if you think about binding a class to itself, right? There's to alias. So alias is a unicorn. Alias is a token that binds to another token, and the instance will actually be the same. So here we have a class of spike and a class of horn, and we bind the spike to alias horn. And now the instance for spike is the exact same object as the instance for horn. So they're interchangeable at that point. The factory function. So here we're binding the class number to a factory function. Exactly like Angular.factory, nothing new here except for the syntax. And we say injector, give me back a number, and it's the sum of 1 plus 1. So you're probably pretty bored. You're like, okay, this is all Angular 1.x, but with an Angular 2 skin. What kind of interesting things are different? Well, Angular 2 injector has some pretty interesting things for asynchronous dependencies. So you can now have an asynchronous factory. And what an asynchronous factory does is you can return a promise, and if it works in combination with async get, it will not resolve the dependency chain until that promise is fulfilled. So this opens up some interesting avenues. For example, here, I'm downloading a list of users, and I'm waiting for those users to be downloaded before resolving the user's controller. So now when somebody asks for a user's controller, they'll get their instance of user controller, but it'll already have the user and the model downloaded async. This is really, really fascinating when it comes down to synchronous UI, right? So if you have React components or Angular components are resolved synchronously, but if you have React components or Angular components that don't want to know how their dependencies or their data is downloaded, they don't have to. They don't have to handle any of that asynchronous state management. They just have to worry about painting data. And the dependency injector takes care of all of the asynchronous behavior. And most of these bindings allow you to specify a list of dependencies. So in this case, we're taking number and we're injecting it to this other token string, and we're just returning back the concatenated value. So the second parameter here happens to be the dependencies that we're injecting in. We got to take a quick detour because I saw how many people raised their hands for the TypeScript and how many people raised their hands for ES5. So this is going to be a little detour into ES7. How many of you guys have looked into what's coming down the road for ES7, which is right after ES6? Okay. I'm going to say a fair amount of people, but it wasn't, unfortunately. What the fetch is this thing? You guys have probably seen a lot of these. You're like, oh my gosh. Is that an annotation? It's actually not an annotation. It's called a decorator. And they used to be called annotations when they were an script, but once things changed a little bit, they're called ambient decorators, which just add metadata to an object. Decorators themselves can actually modify or change the behavior of a constructor function or a parameter. This is really similar to Python-esque decorators, but they're coming hopefully down the pipe to JavaScript. They're already implemented in TypeScript and in Babel, so there's a good chance that they're gonna land. What they do is they receive a target and they can just modify it. So they're just functions. Decorators are just functions, and those functions receive the target and they can change the behavior of them. So here's an example of the inject decorator. We have this function inject, it receives dependency. So this is sort of a higher order decorator, because when we invoke @inject with the horn dependency, that returns a function that then gets invoked on the class unicorn. And then it adds some parameters. What's the ES5 equivalent? Well, this is the ES5 equivalent. So we run inject with horn, which returns a function. We run that on the unicorn dependency, and then that marks it up with some metadata. An example result looks like this. We add inject a parameter, and the result is a property on the class. So DI decorators, one thing that I really like about them is they only add metadata. This is really important because by only adding metadata, they don't change the behavior. You can create the objects yourself without the dependency injector's help. You can still resort to plain old constructor injection. They're not changing the behavior of the constructor function. That's the end of the detour. Hopefully I have your attention because I know that decorators are really different, but they're really cool. Let's talk about some of the decorators available to you if you're going to be using ES6. So this is non-TypeScript. This is more the ES6 route. If you want to inject a horn, rather than using a type annotation, you would just add inject horn, and it would use that token, look up if the token's been registered in the injector, and provide it accordingly. With TypeScript, you have absolutely no machinery. You don't have the decorator. They overload the type annotation, which is so sick. Like, I'm so excited about this because you can share this code now with somebody from another framework, right? If they're using TypeScript, which that one's a little bit more of like a home run, like a stretch. But the beauty is this code is not coupled to Angular 2. Yet it works completely in concert with Angular 2's dependency injector. Inject promise. So if you use injector.get, you have to use async inject promise. Injector.get resolves the promises synchronously, and then you're going to be waiting around for the promise. So here we have a horn that's going to exist sometime in the future. It's an eventual horn, and we set it once that asynchronous factory resolves. Inject lazy. This is kind of interesting because it lets us create dependencies conditionally. So sometimes you have a dependency that in an object that takes a really long time for it to construct, or maybe it does some work, or it's hydrating from some big cache, and you don't want to do it all the time. You only want to do it in certain conditions. Well, inject lazy basically gives you a function you can invoke that will then create that object. So here we're not constructing the unicorn's horn unless it happens to be a full moon. You have optional dependencies. So you can mark a dependency as optional, and this is really interesting because if you have the case of like Angular 1 where you have this jQuery, JQLite, you could inject jQuery, and if they don't have jQuery on the page or they don't have it as part, you get null. And so it's very obvious that they're intending to fall back. But we still have singleton sadness, which is that everything returns a singleton. Like I said in Angular 1, there's two mechanisms, right? There's the token-based mechanism, which returns out singletons, typically, unless you're talking about scopes. And then you have link, which returns scope element attributes, which are order-based. However, those return instances, right? You get a different element every time that directive is created. You get different attributes every time that element is created. So let's say you create an injector. Injector, resolve, and create, and you give it a unicorn, a horn, a material power, everything that you need to create a unicorn. Then you create a child injector. That's kind of interesting, right? We haven't heard of this concept before. What you can do is you can pass resolve and create child, and you can give it a different set of bindings. So here we're calling that with unicorn and horn. Then we're going to make a child of that child with just a unicorn. Now say we wanted to make a new instance of unicorn. Well, it's going to give us the unicorn from that last child because that was the last time it saw the unicorn binding. It's going to get the horn from the second child because that was the last time it got a fresh horn binding. And then it's going to make the material and the power from the parent injector because those are the only places it can find it. So this is pretty interesting, right? Because think about having a third-party library, and they load all their stuff into an injector and they give it to you. And you say, I just want to change out that one class of theirs. You just make a child injector and you register for their token. And now you've hooked in and you've effectively changed the strategy for how their library behaves. Somebody started clapping. Thank you. Thank you. I like that. So this is what child injectors look like. You have resolve and create. And since both of these are created with a unicorn, we are getting separate instances. Here we have resolve and create. We're giving the parent injector a unicorn and a horn. And the derivative injector, the child injector, has a unicorn. Now we expect that the unicorns are different, but they're sharing the same horn object. So you can kind of think of this like prototypal inheritance for dependency injectors. As if, prototypal inheritance, it took me like 6 years to understand that, but now it's the best thing ever. Angular actually creates a separate child injector for each component. Well, they do optimizations, obviously, to make it not as expensive as it sounds, but metaphorically, they create new dependency injectors for each component or HTML element. And so when you have an autocompleter example, like in Angular 1.x, we don't have a separate thing for link as we do from .directive. We just have our autocomplete component, and we can get a new instance of ng element and a new instance of ng attributes, but use the singleton of the autocompleter service. So Angular 2 has a unified mechanism for injecting dependencies, which I think is pretty cool that they solved that problem. So here's an example you can take home and practice with TypeScript, which are using ambient decorators. People, man, I don't know if I'm supposed to call them annotations. When I looked it up, it was all decorators. But you have these decorators for component and view, and then we're just painting name into the component, right? Everyone's seen this Angular 2 example 100 times throughout this conference, and hopefully at home. If we wanted to inject a name service, we literally just have to make a class called name service, and in the constructor, we just reference that token name service. We then provide name service into the bootstrap function, which effectively we'll call resolve and create, and it just wires together to the name service because that's the token that it has. So what's really cool about this is there's no machinery for Angular 2 dependency injection if you're using TypeScript. The type params are overloaded as the tokens. So Angular 2's dependency injection summary, it's straightforward to implement. The code is easy to understand. It looks like vanilla TypeScript. It decouples the client from the dependencies implementation. It's very easy to test because of that. It's simple to create separate instances. You just make derivative inject. I call them derivative injectors. I don't know why. Child injectors. And asynchronous dependencies are supported. I'll ask you guys what dependency injection 3 looks like. What I really admire about what Angular did with dependency injection 2 is they topped themselves. Like, no one came by and said, we can do dependency injection better than these guys. There was a lot of copycats kind of things, but they topped themselves using the same constraints, which I have so much respect for. Thank you guys so much. I would adore questions, feedback, etc. in the office hours. And I'm Merrick on Twitter, and I really appreciate your guys' attention and time. So thank you.